Hello grade 12, Mr. G here. We're going to make another video on organic compounds. This is a question 2 from November 2017. Okay, so let's look at the question. It's a good question to practice, and the question states like, study the structural formula below, and they give you the structural formula of certain compound. For this compound, write down the homologous series to which it belongs. So we have to go here and find out which one is the functional group of this compound. You can see here the functional group is here. It's indicated there. This oxygen is connected to another oxygen, so that is actually the functional group. And if you go to functional group, this is an ester. So it is a ester. The homologous series is an ester. So let's go to the solution here, and this is a ester. If you do that, you will get 1 mark. Okay, so that was the first question, is the homologous series to which it belongs. 2.1.2 IUPAC name. Alright, this is the compound. Remember, there was a video done on this one. You have to come and divide the compound right there, and on this side here, which the O is coming from the alcohol, right, and this other side is coming from the carboxylic acid. All right, and then remember, the alcohol is always first and the carboxylic acid is always second, and you also change the name. So this one, you can see it is a alcohol that actually have 2 carbon, and therefore is ethanol. So we change that one to ethyl, and then that is the first part, and the second is going to be from the carboxylic acid. It is a carboxylic acid that have 4 carbon. That will be a butanoic acid, so it will come butanoate. So this is the name of the compound. I hope is that quite clear. And here the marks are for saying ethyl and the other for say butanoate. There's 2 marks in total for this specific question. Okay, so let's go to the next question. The next question is write down the IUPAC name of the organic acid used in its preparation. Okay, so if you go here, we already separated. We said that this side is coming from the carboxylic acid. This side here is coming from the carboxylic acid. So the carboxylic acid that was used was a carboxylic acid that have 4 carbon, and this is quite clear. So it will be butanoic acid. So we go to question 2.1.3, and the answer is butanoic acid. That is the answer for this question, and you will get 1 mark for that. Okay, let's go to the next question. Next question here said just give me a second to fix this one. Okay, the question says structural formula of its straight chain unbranched functional isomer. Let's record what the functional isomer is. Functional isomer of a ester is a carboxylic acid, and the functional isomer of a carboxylic acid will be an ester. We're looking for the functional isomer in straight chain of the organic compound, which is this one here. So all we have to do is imagine this is a Lego game. We have all the pieces and we convert it into a carboxylic acid. So we have a total of 2, 3, 4, 5, 6 carbon in total. So that's all we are going to do here. We are going to make 6 carbon, but those 6 carbon must be in a straight chain, and the functional group is the functional group of a carboxylic acid. So this is question 2.1.4. We have a carbon, oxygen, hydrogen. This is already converted into a carboxylic acid, and we need 6 carbon. Let's go back. Here it is, 2, 3, 4, 5, and 6. So counting 1 carbon there, 1, 2, 3, 4, 5, and 6, and the rest will be fixing the hydrogen. Okay, So all we have to do is this one. This is like the Lego game, and we are now fixing the pieces. We changing the ester into the carboxylic acid. Okay, so if we count, we have 1, 2, 3, 4, 5, 6 carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogen and 2 oxygen. Now you don't have to do this one, but it's good to count. Okay, if you go to the actual, you have 1, 2, 3, 4, 5, 6 carbon. You have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogen and 2 oxygen. We have the same molecular formula. Okay, so the same structural formula of its straight chain and branch functional group. That is the answer, and the marks here will be as follow. 1 mark will be for the functional group corrected. It must be correct. 1 mark for that, and the second mark for the whole structural formula. There are 2 marks. Okay, so everything must be corrected, and then you will get the second mark. Let's go to the next question. Next question is 2.2. Write down the structural formula of, and they're giving you this compound. Let's go and answer this one. Okay, to do this, we're going to start with pentan. Now remember, pent is 4, 5. So we're going to have 5 carbon in a straight line, but I'm not going to connect any carbon. 1, 2, 3, 4, and 5. The second step here is to identify the functional group. This is a ketone which is in the second carbon. So I'm going there, and in the second carbon, I'm going to draw or write the functional group of a ketone. There we go. Then I'm going to the, finally, I will go to the substituent. The substituent, we know that we have a methyl in carbon number 4. So if we're counting from the beginning, this will be carbon number 4, and there is a methyl. Everything must be in structural formula because that is the question. So the rest is connect all the carbons and add the hydrogen. Remember, every carbon must have 4 bonds. So this one is the structural formula of 4-methyl pentan 2-on. I hope it's clear and it's not that difficult. Now the marks here are given for the functional group. The functional group corrected in the second carbon. There it is, with the carbon. And then the other one is for the methyl. This one is 3 marks for this specific question. The other one is for the methyl corrected, allocated, and the last one is for the whole equation, okay, or the whole formula. Here is 3 marks for this question. Okay, let's go to question 2.3, and now 2.3 have part. You have a compound. Let's consider the structural formula below. First of all, for this compound, write down the general formula to which of the homologous series to which it belongs. If you go here, you can see that the compound is a alkyne. Here is the triple bond between carbon atom. It is an alkyne. So the first one is the general formula, and the second question is the IUPAC name. So let's write down the general formula of this compound quickly, and then the name. Question 2.3.1. 2.3.1. The general formula of alkyne is CnH2n-2. You have to learn the general formula of the different homologous series, okay? And there is 1 mark for writing that general formula. Okay, the last question is question 2.3.2, which is to write the name of that specific compound. Alright, here we have the compound. Remember, the step 1 is to identify the homologous series, which we already did, and will be an alkyne, and the 4 will finish in -ile. Okay, in -ine. Alright, that is the first part of the first step. Second step is to identify the longest continuous carbon chain. We have many options here. This one is 1, and in this one we have 1, 2, 3, 4, 5, 6, 7 carbon, but there is more options which I'm going to show you. However, you will see that this one is the longest one. So we can have this option here. Now this one will have 1, 2, 3, 4, 5, 6, 7 as well. So it is the same one. We are going to ignore that one. We have the other option, which is right here. That one will have 2, 3, 4, 5, 6, and 7, the same one. So we're going to ignore that one as well. And the last option could be like it is here. You can see there, and is 1, 2, 3, 4, 5, 6, and 7. So either one we select is going to be 7. So therefore we're keeping that one. Now 7 is hept. All right. So it's going to be hept. Then you are going to count the carbon starting from the end nearest to the functional group. In this case, you can see that the shortest one is starting from the back. So it's 1, 2, 3, 4, 5, 6, and 7. If you're starting from the back, is 1, 2, 3, and 4. Okay, so from there is better. And we're going to come down here and write in what carbon is the triple bond. I'm going to write it with the same color of the number. Now we are going to look for any substituents. Here we have a methyl. And here we have another methyl. This one is in carbon 6. This one is in carbon number 2. Remember, we have two of the same substituents. Then we combine the numbers to 2,6 dimethyl. That is the first substituent we have. And here on top we can see that there is an ethyl. And that is in carbon number 5. So we have now the substituents, we have the number of carbon, we have the functional group. The only thing that we have left is to write the name. So let's write the name here at the bottom. First the substituent in alphabetical order. So it will be 5-ethyl 2,6 di. There is a dash between dimethyl hept 3-ine. That is the final answer for this compound, and there are 3 marks for that. You will get 1 mark for each part here. The first one for the substituents. You get another mark for this part here, and 1 for the final part of the question. Those are 3 marks. Okay, that was the question. I hope it is clear. It's a good question to practice. You're starting with an ester. Later on we'll make videos on esterification, not now. And up until next time, come ready. We are going to make a video on physical properties. Okay, thank you very much, and good luck.